So you may know a little bit of trigonometry, maybe from advanced functions or something like that. If you have sine of 30 degrees, that equals to 1/2. It's a special angle. Um, but you may also know that sine of 150 degrees, well, that's also going to equal to 1/2. We've got this cast rule, and the sine is positive in the first two quadrants. So a 30-degree angle and a 150-degree angle, it's actually going to give the same answer for sine. So there's two answers to this equation. If sine of x equals 1/2, what does x equal? It could equal 30, or it could equal 150 degrees. There's two answers. And because of that, when you look at this range formula for projectiles, it uses sine there, and it turns out that two different launch angles could produce the same horizontal range using the same launch speed. And I just kind of wrote the summary at the beginning here. Angles of theta and 90 minus theta will give you the same horizontal range. And your immediate question may be, how come it's 90 minus theta when the identity says 180 minus x? Well, that's because the range formula is not theta. The range formula is 2 theta. It's been doubled, so that's why. Yeah, that's just me briefly talking about those details. You can think through it more carefully if you want to. But at this point, you can take that as a fact when you go and do your problem sets and your quizzes and all of that. So for this example here, ball is launched at 30 meters per second. That'll be the launch speed. And which two angles will create a horizontal range of 40 meters. So r equals 40. And this time we are solving for theta. So we take that formula that's up there. And we rearrange it a bit. So right now I'm debating whether to put in the numbers and then rearrange, or to rearrange and put in the numbers. I think rearrange first and then put in the numbers. So I'm going to isolate for theta. So that's going to involve first multiplying both sides by g and dividing both sides by v1 squared. That'll give me sine of 2 theta. And then I would take the inverse sine of both sides. So 2 theta would be the inverse sine of this fraction. And then, so theta, so if I divide that by 2 or multiply by 1/2, theta would be 1/2 of the inverse sine of this fraction. And the inverse sine of that fraction has two answers. The calculator is going to give you one of the answers. So let's see what the calculator gives us for one of the answers. So I'll fill in the values here. Range was given as 40 times g 9.8 over v1 squared, 30 squared. So quick check, looking good because the fraction is going to be between 0 and 1. So let's type this in the calculator here. 1/2 times sine inverse Okay, so this is giving me 13 degrees if I round it to 2 sig figs. So that's one launch angle. The other launch angle, if you go back to what I highlighted at the very top there, the other launch angle will be 90 minus 13 degrees, which is 77 degrees. If you want, I mean, you can always check, right? You can always check by calculating the range again. So I go 30 squared times sine of 2 times 77. So 2 times 77 over 98. And we'll just check and see if this gives me 40, which is supposed to be the range here. And yes, it does. So we're good. The calculator is showing 40.3. So what's with that 0.3? Well, that's because this 13 was rounded, so it's not totally precise here. All right, so two different angles can give you the same level horizontal range.